Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. As organizations grow their workloads in AWS, protecting data from accidental deletion, corruption, or disaster becomes a central concern. AWS provides two complementary pillars for this. AWS Backup, a centralized service for managing backups across AWS services, and the Amazon S3 Glacier family, which offers ultra-low-cost storage tiers for archiving long-lived or compliance-driven data. Together, they form the foundation of resilience and long-term retention in AWS. Backup provides structure, scheduling, and governance for short to medium-term recovery, while Glacier ensures that vast amounts of historical or regulatory data can be retained at minimal cost. The AWS Backup Service simplifies the complexity of creating and managing backups by offering a central control plane. Instead of separately configuring snapshots for each service, Backup provides policies that apply across multiple resources, ensuring consistency and reducing administrative burden. It is designed to be policy-driven and automated, enabling organizations to implement enterprise-wide protection strategies rather than ad hoc processes. This makes AWS Backup suitable not only for IT teams managing diverse services, but also for compliance and governance teams that need centralized visibility into backup coverage. A wide range of services are supported by AWS Backup, including EBS volumes, EFS file systems, RDS and Aurora databases, DynamoDB tables, FSx file systems, and even storage gateway volumes. The breadth of integration ensures that nearly all data-bearing services in AWS can be covered under a single framework. This eliminates gaps where teams might otherwise forget to configure protection. For example, the same backup policy can protect a database cluster, its associated EBS volumes, and its shared file systems, ensuring holistic coverage without requiring custom scripts. Backups in AWS Backup are organized using three main building blocks: backup plans, selections, and vaults. A backup plan defines the policy, when backups run, how long they are retained, and where they are stored. Selections map resources to those plans, often using tags to dynamically include resources as they are created. Vaults are the logical containers where backups are stored, providing both organization and security. This separation of concerns ensures that policies are reusable, resources are easily onboarded, and storage remains well-governed. Within backup plans, administrators define schedules, backup windows, and retention policies. Schedules determine how often backups occur, such as daily, weekly, or hourly. Windows define when backups should start, giving administrators control to avoid peak workload hours. Retention policies automatically expire and delete old backups, preventing uncontrolled growth in storage costs. Together, these elements provide both the rigor of compliance and the efficiency of cost management. For example, an RDS database may be backed up nightly with a retention of 30 days, balancing operational recovery with storage expenses. AWS Backup also supports cross-account and cross-region copies, which strengthen both resilience and compliance. By copying backups into another AWS account, organizations protect against accidental deletions or insider threats in the primary account. By replicating across regions, they prepare for large-scale disasters or regional outages. These features extend protection beyond local resilience, ensuring continuity even in rare but impactful scenarios. Enterprises often use this capability to meet regulatory requirements for geographic redundancy. Backup targeting can be driven by tags, which allows governance teams to enforce coverage without manual oversight. For example, all resources tagged critical = yes can be automatically included in a backup plan. This eliminates the risk of new resources being created without protection. Tag-based selection also supports chargeback and accountability, making it clear which business units own which backup costs. Tags elevate backups from technical configuration into an enforceable governance mechanism. Monitoring backup activity is built into the service. AWS backup reports provide compliance evidence, showing which resources are protected, when backups occurred, and whether jobs succeeded or failed. Job monitoring ensures that failures are detected quickly, preventing false confidence. These compliance reports are essential for audit purposes, giving organizations the documentation they need to prove adherence to regulatory standards. Visibility transforms backups from background processes into accountable, reportable safeguards. When recovery is needed, restore workflows allow backups to be used to recreate resources. For EBS, this means creating a volume from a snapshot. For RDS, restoring a new database instance. For DynamoDB, seeding a new table from a backup. These workflows prioritize flexibility, allowing restores into different accounts or regions if needed. The goal is not just data preservation but usable recovery, ensuring that backups translate into business continuity rather than static archives. Permissions are central to securing backups. AWS Backup uses IAM roles to define who can create, manage, and restore backups, while KMS keys handle encryption at rest. Each vault can be associated with specific KMS keys, allowing fine-grained control over who can access the data. For example, sensitive workloads may use customer-managed keys with limited access, ensuring that only approved administrators can restore data. By combining IAM and KMS, organizations build layered defenses around their most valuable data. Cost for AWS Backup consists of three components: storage, restores, and copies. Storage charges are based on the volume of data retained in backup vaults. Restores incur costs when data is rehydrated, and cross-region or cross-account copies add replication expenses. While backup storage is cost-efficient compared to on-demand snapshots, restores and replication must be budgeted carefully. Awareness of these cost drivers ensures organizations align protection strategies with financial constraints, avoiding surprises when large-scale restores or migrations are required. While AWS Backup handles active protection, long-term archiving relies on the S3 Glacier family. Glacier offers three main tiers: instant retrieval for archives that need millisecond access, flexible retrieval for data that can tolerate retrieval windows of minutes to hours, and deep archive for the lowest cost, multi-decade retention with retrieval times of up to 12 hours. By aligning Glacier tiers to access patterns, organizations achieve durable, low-cost storage for compliance or historical data. Glacier complements backup by ensuring data that no longer needs immediate recovery is retained cost-effectively. Retrieval from Glacier is governed by both timeframes and request classes. Instant retrieval is priced higher but delivers rapid access. Flexible retrieval provides options for bulk restores at lower costs, while Deep Archive emphasizes affordability at the expense of retrieval speed. This tiered model ensures organizations don't overpay for fast retrieval when it's unnecessary, but can still access data when compliance or business needs arise. It introduces a discipline of thinking about not just whether data is saved, but how quickly it must be recalled. Use cases for Glacier span compliance, long-term retention, and cost control. Financial institutions use Deep Archive to retain transaction records for decades at minimal cost. Healthcare organizations store medical imaging data in flexible retrieval, balancing availability with budget. Media companies archive raw footage into Glacier, ensuring they can access it years later if needed. These use cases illustrate Glacier's role as the cloud equivalent of tape storage: cheap, durable, and accessible when required. It completes the data lifecycle by ensuring that no matter how old or rarely used data becomes, it can still be preserved economically. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Designing backup strategies begins with aligning them to RPO, Recovery Point Objective, and RTO, Recovery Time Objective. RPO defines how much data loss an organization can tolerate, while RTO defines how quickly services must be restored. For a production database, an RPO of 1 hour and an RTO of 4 hours might dictate frequent backups and the use of faster storage tiers for recovery. In contrast, archival workloads with relaxed RPO and RTO can be safely sent to Glacier Deep Archive. By anchoring strategies to these objectives, AWS Backup and Glacier become tools to meet business outcomes rather than abstract technical goals. Different AWS services integrate into AWS Backup with specific workflows. EBS volumes rely on snapshots that capture block-level changes. RDS and Aurora databases support full backups and point-in-time recovery within defined retention windows. EFS file systems can be backed up at the file system level, preserving directory structures and permissions. DynamoDB integrates with backup as well, though it also has its own built-in point-in-time recovery (PITR) feature. These service-specific integrations ensure that each workload type is protected appropriately while still being managed centrally under AWS Backup's plans and vaults. With DynamoDB, administrators must understand the difference between PITR and scheduled backups. PITR provides continuous protection, allowing restores to any second in the last 35 days. Scheduled backups created through AWS Backup provide point-in-time snapshots that can be copied across regions or retained beyond PITR's time horizon. PITR ensures operational resilience for recent data, while scheduled backups support long-term compliance and disaster recovery. Using both together creates layered protection for critical workloads where downtime or data loss would be unacceptable. A frequent area of confusion is the difference between Backup Vault Lock and S3 Object Lock. Both enforce immutability, but they operate in different contexts. Vault Lock applies to AWS Backup vaults, ensuring that no backup can be deleted or altered before its retention expires. Object Lock, on the other hand, applies to individual S3 objects, typically used for compliance archives or warm retention on S3 buckets. Vault Lock is for backups across multiple AWS services, while Object Lock is for direct object storage governance. Understanding the distinction ensures that the right control is applied to the right use case. Security extends beyond immutability with end-to-end encryption. Backups can be encrypted using customer-managed KMS keys, ensuring that both the data at rest and copies across regions remain under strict key control. However, using customer-managed keys introduces operational responsibility. If the key is disabled or deleted, restores may fail. Organizations must carefully manage key policies, rotations, and access scopes to balance security with availability. By embedding encryption into every step of the backup lifecycle, from creation to recovery, sensitive workloads remain protected against both external and internal threats. Resilience requires more than just creating backups. It requires testing restores. Regular recovery drills, often called game days, validate that recovery processes work as expected. A backup that cannot be restored quickly enough to meet RTO is effectively useless. Organizations should periodically restore sample backups into test environments, verifying data integrity, access policies, and performance. These drills not only expose gaps in planning, but also train staff to respond effectively during real incidents, reducing panic and error when recovery truly matters. Long-term retention often involves lifecycle transitions into Glacier tiers. Data that starts in S3 Standard can automatically move into Glacier Instant Retrieval, then Flexible Retrieval, and finally Deep Archive, guided by lifecycle rules. For example, log files might remain in Standard for 30 days, then move to Flexible Retrieval for 1 year, and finally into Deep Archive for compliance retention. This tiered approach aligns storage costs with data value over time, ensuring that organizations never overpay for storage while still preserving access to historical records when required. Planning restores from Glacier requires understanding partial and full recovery workflows. Some workloads may need only a subset of data restored. For example, retrieving a single month's worth of archived logs. Others may require complete restores, such as rebuilding a legacy system for compliance investigations. Glacier supports granular restores, but retrieval speed and cost vary depending on the chosen tier. Aligning restore planning with expected business scenarios prevents shocks when recovery requests arise. It ensures that retrieval times and fees are anticipated rather than disruptive. For true disaster recovery posture, cross-region strategies are essential. Backups can be copied automatically into another region, ensuring resilience even if a regional outage occurs. Seeding strategies often involve initial large-scale transfers followed by incremental updates, reducing bandwidth demands. By planning cross-region copies, organizations achieve geographic redundancy without having to replicate entire environments manually. This not only satisfies regulatory requirements but also provides a genuine safety net for catastrophic events that could compromise primary workloads. Compliance evidence is a recurring theme in backup governance. AWS Backup provides reports and logs that prove backups were taken, retained, and secured according to policy. Access logs demonstrate that only authorized users have restored or modified backups. Retention policies enforce compliance mandates, such as retaining healthcare records for 7 years. These evidence artifacts simplify audits and reduce the operational burden of proving compliance. Backup reporting transforms resilience from a claim into a documented reality. One common challenge in Glacier is unexpected retrieval costs and early deletion fees. If data is archived into Deep Archive but accessed sooner than the minimum retention period, early delete charges apply. Similarly, retrieving petabytes of data in bulk can generate unplanned expenses if not budgeted for. To avoid cost shocks, organizations must classify data carefully and set expectations about retrieval frequency. By matching Glacier tiers to true access patterns, storage costs remain predictable and sustainable over time. Automation strengthens resilience by ensuring backups are never forgotten. Event-driven backups can trigger whenever new resources are created, while remediation policies can detect unprotected resources and automatically apply backup plans. This automation closes gaps that arise from human error or oversight, ensuring that every workload is covered. By embedding backup enforcement into resource lifecycle events, organizations guarantee continuous protection even as environments evolve dynamically. Despite these tools, pitfalls remain. Untagged resources may escape protection if backup plans rely solely on tags. Vault lock may be configured incorrectly or left unused, weakening compliance posture. Encryption keys may be scoped too broadly or too narrowly, leading either to security risks or restore failures. Awareness of these pitfalls, combined with disciplined governance, ensures that backup strategies achieve their intended resilience without introducing hidden risks. In both exam scenarios and real-world practice, the distinction between AWS Backup and Glacier becomes clear. Backup provides policy-driven cross-service protection-defining schedules, retention, and vaults for consistent resilience. Glacier provides archival storage, ensuring data can be preserved for years or decades at minimal cost. If the question emphasizes governance and automation, backup is the answer. If the emphasis is on long-term retention and retrieval economics, Glacier is the solution. Together, they form a complementary strategy for protecting, retaining, and recovering data across its lifecycle. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.